Hello students, in this video we are going to discuss 6.5, 6.6, 6.7 and 6.8 from electromagnetic induction. A 1 meter long metallic rod is rotated with an angular frequency of 400 radian per second about an axis normal to the rod passing through its one end. The other end of the rod is contact with the circular metallic ring. A constant and uniform magnetic field of 0.5 Tesla parallel to the axis exists everywhere. Calculate the EMF developed between the center and the ring. So we can take the situation like this. This is circular ring. Where it is placed in a uniform magnetic field. And from the center to here, so there is a rod. Now this rod is rotating. Then what is the EMF developed at the end of the rod? EMF developed between the center and the ring. Here, the given values, the length of the rod is given as 1 meter. And omega is equal to 400 radian per second, and magnetic field B is equal to 0.5 Tesla. In this case, the induced EMF E is equal to half B L square omega, that is equal to half 0.5 into 1 square into omega. So its value will be 100 volt. Coming to 6.6. A horizontal straight wire 10 meters long extended from east to west is falling with a speed of 5 meters per second at right angles to the horizontal component of Earth's magnetic field, 0.3 into 10 power minus 4 Weber per meter square. What is the instantaneous value of the EMF induced in the wire? What is the direction of the EMF? Which end of the wire is at the higher electrical potential? Now here, the given data is length of the wire is 10 meter. It is falling with velocity 5 meters per second. And the magnetic field is nothing but horizontal component of Earth's magnetic field. Its value is 0.3 into 10 power minus 4 Weber per meter square. Now we need to calculate instantaneous value of EMF, that is nothing but induced EMF, that is nothing but BLB, but here B is nothing but BH, that is equal to 0.3 into L value is nothing but 0.3 into 10 power minus 4 is B value, and L is 10, velocity 5. So its value is 1.5 into 10 power minus 3 volt. Coming to B, what is the direction of the EMF? The direction of the EMF is from west to east. We can find out this one with the help of Fleming's right hand rule. See, which end of the wire is at the higher electrical potential? So the answer is the eastern end will be at a higher potential. Coming to 6.7. Current in a circuit falls from 5 ampere to 0 ampere in 0.1 second. If an average EMF of 200 volt induced, give an estimate of the self-inductance of the circuit. Here, di by dt is nothing but 5 minus 0 divided by 0.1. That is 5 by 0.1, 50 ampere per second. And average EMF E is equal to 200 volt, that is induced. Now we need to find out the self-inductance. We are having E is equal to L di by dt. So from this, E value is nothing but 200, that is equal to L di by dt is nothing but 50. From this, L is equal to 4 Henry. Coming to 6.8. A pair of adjacent coils has a mutual inductance of 1.5 Henry. If the current in the one coil changes from 0 to 20 ampere in 0.5 second, what is the change in flux linkage with the other coil? Here the given values are mutual inductance M is equal to 1.5 Henry and the current changes from 0 to 20 ampere in 0.5 second. Then what is the change of the flux linkage? So we can write change in flux in second coil is equal to M into change in current in the first coil. How we got this formula? E is equal to d phi by dt. If you take the magnitude, that is nothing but M di by dt. So from this, d phi is equal to M di or delta phi is equal to M delta I. That is equal to 1.5 into 20 minus 0. That is equal to 30 Weber. So these are the solutions from EMI. Kindly subscribe the channel. I hope these solutions will be helpful for you. Thank you.